Here we are at example 7 from our 1.4 set of notes. We're asked to determine where, in fact, is this function continuous. And we see that we have a rational function, and here is, in fact, the graph along with that. Now, as we talked about from example 6, you cannot have the bottom equal to 0. Each individual piece are continuous, and when you take the collective, that is also continuous, likewise with this division symbol. But the bottom cannot be equal to 0, and the goal here is to solve for x and determine where are we seeing that discontinuity. Now, if we go ahead and factor out the bottom, we have x minus 4 times x plus 1 is not equal to 0. And then just using that zero product property, breaking this up, we end up with x minus 4 is not equal to 0. And x plus 1 is not equal to 0. Going ahead now and solving for each one, we end up with x is not equal to 4 and x is not equal to -1. Now, just looking at our graph, we can see very clearly that 4, we see that vertical asymptote, but at -1, there's nothing really showing up here. And as a result, it kind of leads me to at least assume that there's probably a hole there. Now, keep in mind, a hole is still a form of discontinuity. Okay, so we've done all the proper channels of solving for this and for that discontinuity. Just looking at the top, if you were to factor that out, that would come out to be x squared minus 2 times x squared minus 1. And this guy we can't really factor out anymore, so he's still x squared minus 2. But this guy over here is the difference of two perfect squares, and that would factor out to be x plus 1 times x minus 1. And lo and behold, this guy was on top, this one was on bottom. They would cancel, thus creating that hole at -1. And again, though, that is still a form of discontinuity. So it is important to keep that in mind for your actual interval notation and where that is, in fact, continuous. All right? Now, the main reason why we're showing this example is you cannot solely depend on your calculator, because again, it can be a little bit more, it can misinform you is the best way I can describe it, because in fact there is that hole there, which is a form of discontinuity. Now, where is our function in fact continuous? From -infinity, as you guys can see, up until -1. Can't be -1, so we have a parenthesis around him. -1 kicks in again, goes till 4. And then right after 4 and on towards positive infinity. So again, really the purpose of this example was just to show you that your calculator can kind of mislead you if you're just looking at a pure image of it and not really taking into account potential holes that are there. All right? And again, that has to deal with screen resolution. Sometimes they can't get infinitely close to a certain thing because they're working in pixels. So again, though, that is example 7 from our 1.4 set of notes.